this is the reverb chamber here next to us. A reverb chamber is simply a chamber for testing wireless devices. It allows us to do an over-the-air test, and it allows us to do the over-the-air test in the far field of the antenna pattern, so that we are testing a device in the same conditions that a customer would be using it when they're in the field. The really interesting thing about our reverb chamber, when combined with our channel emulator, is that we can develop a wide range of over-the-air conditions. So our reverb chamber essentially creates an isotropic field, which means we're able to test the device from all angles of arrival. And by pairing it with our channel emulator, we can apply all sorts of fading profiles to really test the device in all the different environments. If you were to look through the standards for the latest wireless protocols that are developed by 3GPP and CTIA, you would see several different standard channel models. And those channel models reflect urban environments, rural environments, with different correlation. And correlation simply means the degree to which different spatial data streams correspond to one another or not. In order to develop maximum data rates of LTE and other 4G protocols, you need independent data streams. And when the wireless channels themselves become correlated, then they're no longer independent. And there's a limitation on the maximum amount of data you can transmit. So when I have my reverb chamber and I'm able to test devices with correlation, I can measure the impact of correlation, and I can measure the impact of these different channel models and different real-world situations on the performance of the device.
So how do you get far-field signal emulation in a box that's roughly 2 meters wide?
Well, I think, Jeff, I got to tell you, it's a function of the math. The really cool thing about a reverb chamber is that all the reflections, when you do the analysis, can actually be represented by 8 plane waves. And a plane wave is simply kind of a flat wavefront, just like we describe. And that's the really cool thing about it, is that you can have all these reflections, hundreds, thousands of reflections, more. But it can all be represented by 8 plane waves, so that we can really understand how the device performs. And so creating those far field effects with plane waves in such a small chamber is actually pretty remarkable.